Welcome to Math Proofs. My name is Adioja, and today we're going to be proving the logarithm power rule. And what this rule states is that the log base a of b to the power x is equal to x times log base a to the power b. And basically what the rule is doing is it's saying that if you have a logarithm in which you're taking the log of something to the power of something else, you can take that exponent and you can just plop it down right next to the logarithm, which is what we do on the right-hand side. And in order to continue with this proof, we're going to define a few things. So I'm going to take this section over here, log base a of b, and I'm going to define that as being equal to c. Then I'm going to take the other side of this equation and I'm going to set this equal to d. So what I have done is I've just taken the two logarithm expressions in this law and I've made them into variables. So now what we're going to do with these expressions is we're going to convert these logarithms into their exponent forms. And to give you an idea of what I mean, let me give you an example. I know that log base 2 of 8 is equal to 3. And if you were asked to convert this into the exponent form, because logarithms are just representations of exponents, what you would do is you would take the bottom number, the base, that's 2, to the power of whatever this number is, 3, and set that equal to whatever number is being taken the log of, 8. And we know that 2 to the power 3 is equal to 8. So that's how we know that these two statements are true. So we're going to do the same thing with our equations over here. So for the expression in C, we're going to say that A, the bottom number, to the power of C is equal to this number right here, what we're taking the log of, B. And in a similar way, we're going to do the same thing with this D expression. We're going to say that A to the power of D will be equal to B, but not just B, B to the X, B to the power of X. Now moving forward with our proof, we have this expression down here, and we have this B term. And I know from the top equation that B is equal to A to the power C. So we can substitute A to the power C into this bottom equation. So let's rewrite this equation right up here. We have A to the power of D. That's going to be equal to B to the power of X. But in our case, B is equal to A to the power C. And using our logarithm rules, our exponent rules, we can simplify this to say that A to the power D equals A to the power C times X. Now, how do we move on from here? Well, given that we have two exponents and they have the same base, I can say that D is equal to C times X. And for those of you who are a little confused, let me offer you an example. If we knew that 2 to the power 3 was equal to 2 to the power 4 plus x, then I would say that 4 plus x has to equal 3. And the reason is that this side over here is 2 to the power 3, and on this side we have 2. So in order for these two sides to be equal to each other, this exponent right here has to be equal to 3. That way both sides are equal to 2 to the power 3. So I would say 4 plus x is equal to 3. Same thing that I'm doing over here. Now here's where the final part of the proof comes in. We have this expression D equals C times X. But what do we know D is equal to? Well, D is equal to log base A of B to the X. And What is c equal to? Well, c is equal to log base a of b. And then we have an x left over. This x just comes down right over here. So in the end, because d is equal to c times x, log base a of b to the x is equal to x times log base a of b. Hopefully you can see how this proof will work for any numbers. We set two arbitrary equations over here for c and d. We were able to convert these logarithm equations into their exponent forms, and then through algebraic manipulation, we were able to come up with this expression. This has been a Math Proofs video. My name is Adioja. Thank you for watching.